All right, here we go again. Let's go ahead and start figuring out how to get this thing into our alarm signal 1 transition. And it looks like we don't already have that copied down yet. So let's go ahead and take that out of there. Come down here. And I'm just going to drop that in here, and we're going to try to set that equal to 1. So that'll be a colon equal 1 semicolon. And what's our condition going to be? If, and we want to know if an alarm exists. So we don't actually have anything called alarm exists. So let's go back into our main routine and create something else that's useful. So we're going to say if, and let's start looking at these alarm values. So we've got HH underscore temp underscore ALM, or we want to look at LL underscore LVL underscore ALM, or HH underscore LVL underscore ALM. Then we're going to set something called alarm exists. So we're going to say ALARM underscore EXISTS colon equals 1 semicolon. And alarm exists bool yes, and then else, and we're going to set that equal to 0. So just like that, we've got this alarm exists bool, and we can go ahead and end if. So now we can look at that alarm exists, and we don't even need to worry in our process about what that alarm is. If there is an alarm, we need to go to stability mode, and that's going to resolve it. So back to startup. Now we can look back and say if, and let's go ahead and take PLC program dot alarm exists then, and we're going to set that alarm signal 1 equal to 1. And we can go ahead and end if, because setting that equal to 0 is going to be done elsewhere. So we don't have to worry about an else and controlling that from in here. Done. So now we can get into this routine. It does everything that it needs to do, and then at the end it's going to kick us out. We're either going to go into operation mode, or we're going to go offline, or we're going to have an alarm and we're going to jump into an alarm mode. Alright, so let's go ahead and close out of here, and I think our startup is looking pretty good. Let's come down here and let's get into our operation. So operation needs to be a CFC, and this is where we're probably going to spend most of our time. This is where we're going to be leveling up and down and controlling our temperature, and it sounds like this would be the meatiest of the sections. I really don't think this is going to be a very meaty program, but we are going to have to recreate some of the same logic that we just got done laying down in startup, but we're going to have to be recreating that using a different paradigm. So, you know, that's kind of part of the fun, is it's forcing us to flex our muscles a little bit. So let's jump in and figure out what we need to do, and what we're going to start off with is let's look at the level. We need to deplete our tank, fill our tank back up, so that's pretty simple stuff. Well, we can probably borrow some stuff from alarms, so let's go ahead and start by just borrowing out one of these chains that we've created in here. I'm going to copy that. And then let's come back into our mode control and then go back into operation. And I'm just going to paste those right up here. So now we've already got something to look at. And actually I grabbed temperature. What I really wanted to grab was level, but that's okay. We can start with temperature. That's fine. So now we're not worried about our temperature being greater than. We're worried about our temperature being less than, because that's when we're going to energize our heater. So if the temperature is less than, and we can go ahead and just use a static value here, we know that our temperature needs to be between 400 and 500 degrees. So I'm just going to type in a static tag of 400 there. And if we're less than 400, and then we remember that our devices, we want those to all be on a certain delay, well, we're also going to have a delay here to even send that signal. So I'm just going to make this a 5-second delay. And if we're less than 400 for 5 seconds, then we're going to go ahead and call in our main program, we're going to call our heater trigger. So that's going to be dot, and we're going to call heater start. There we go. And let's see. We've got these two things are called other names now, so we need to go ahead and redo those. So what are we going to call this? We'll go ahead and call this heater underscore call delay. And that'll be a TON. And we can go ahead and call this ONS. I think we're up to maybe 7. I don't think it's really going to interfere because we're in a different program file now. But just in case, I'm just going to go ahead and call it ONS 7. So yeah, if our temperature is low, then after 5 seconds of it being low, we're going to one-shot and we're going to tell the heater to start. Perfect. And now that we've got that, it'll be real easy to copy and paste and set that up as the opposite side. So if our temperature is greater than, and we know we want to be between 4 and 500 in this mode, so if we're greater than 500 after 5 seconds, we're going to have a heater kill delay. That'll be a TON. We will have one-shot 8. That'll be a rising trigger. And instead of heater start, that will be heater stop. Okay, and just like that, we've already got our temperature control circuit. Let's go ahead and work on our level. So let's just go ahead and go back into alarms, and now let's copy out our low level chain, because I think that's already going to be pretty similar to what we need. Let's go back into mode control and normal operation. Let's paste that chain in here, and I'll go ahead and space it out a little bit more and just be generous. So we're looking at our level, and we're going to see if it is lower than what? Well, we want this thing to be maintained between 20 and 80%. So if we're lower than 20, then after 5 seconds, we want a, and we'll call this a pump call delay. So pump underscore call, that'll be a TON. This one shot is now going to be ONS 9, okay? And in that event, what we're actually going to call is going to be pump underscore start. And we can copy that, bring it down here, and we already know where we're going with this. We're going to be looking for us to be greater than 80. So that's going to be a GT comparing level to 80. Same 5 seconds. And instead of pump call, it's going to be pump kill. I just like the way that sounds. It sounds so nefarious. One shot 10. And we're going to be energizing pump stop. And so now we've got the pump running on level control, but there's another device we need to be controlling on level, and that's going to be our valve. And I will just come up here and bring down a box, and this box will be a move. And what we will move is, let's come down here and pull in a tag, if it'll let me. There we go. And we're going to move 1 into, let's go ahead and put one more variable over here. That's going to be PLC underscore program dot, and this is going to be our valve open. So we're just going to perpetually send that valve open signal. We always want our valve to be open while we're in this mode, and that's the whole purpose, is to be supplying something out. So now we can control our heat, we can control our pump, and so that pump is going to control our level. Our valve is going to be draining our tank, but we're going to turn the pump on whenever we need to go ahead and bring that level back up. The only other thing that we need to do now is we need to work on our transitions. So let's close out of here for just a second. We've got two transitions we need to work on. We need to work on alarm signal 2, and we need to work on offline signal 2. Well, offline should be pretty easy. So let's take that and jump back in and see how we can control that. We will go ahead and take another move block. So I'll just come down here and type MOVE. Let's bring down another tag, and this time I'm going to paste in the name of that transition. So we've got our offline signal 2, and what we're going to be looking at is simply our button. And that's going to be in PLC_program, and we're looking for our system stop button. So if anyone pushes the system stop push button, that's instantly going to transition us right out of here. And let me go ahead and work on my spacing a little bit, not be so generous, because I also want one more of these moves up here. So what if we need to go into an alarm or a stability mode? Well, we're going to come back into our main program once again. And now we're going to look for our alarm exists, and we're going to move that into our alarm signal transition. And just so I can make sure I get the exact name, let's go ahead and copy it right out of there, come back in, and paste it. So that's going to be a bool for sure. There we go. So now we've got our transitions out of here into offline mode or into our stability mode. And I think we have the control logic necessary to make sure that we maintain our temperature and we maintain our level. So I think we're already good on that piece. Now I'm going to go ahead and take a break, because if I try to jump into stability right now, I think that's going to take a little bit more time. We're going to have to end at an awkward place, and I'm going to see if I can't just knock that whole thing out in one lecture. So I will break here, and when we come back, we will try to set up the programming for stability. We've already got our hour meters and things like that built in. Now we just need our control logic. So go grab that Mountain Dew, and I'll see you in yet another long programming session.